Hi everybody. So here we've got a past exam question on the ellipse. We're given this equation here, and we're told that the line L is normal to the ellipse at the point P. And we're told that theta ranges from 0 to pi over 2. For part A, we need to show that this is the equation of a normal at point P. And then in part B, we need to use this equation. So I encourage you to give this question a go yourself. If you want to try and derive this equation for a normal, you can pause the video and come back when you're ready. Okay, so welcome back if you had a go. So with questions like this, I think it's really helpful if we begin by sketching the ellipse within the range of 0 to pi over 2. So when theta equals 0, the x-coordinate will be 5 cos 0, so this will be 5. And the y-coordinate will be 3 sine 0, so that'll be 0. So we'll have this point when x is 5. And then when theta is pi over 2, our x value will be 5 cos of pi over 2, which is 0. And the y value will be 3 sine of pi over 2, so that'll just be 3. So we'll have a y value here. And I'll sketch that ellipse. So it should look something like this. And then we're told there's a general point P, I'll label that here, and a normal passing through P. So it passes through a curve at 90 degrees. And this is line L. So we need to work out the equation of this line. And because we were told to use calculus, we're going to begin by finding the equation of a tangent to the curve at P. So I'll label this green line T. This is the tangent to the curve at P. We know the gradient of a tangent will be the negative reciprocal to the gradient of the normal. So to work out the gradient of a tangent, we could either differentiate this implicitly, or we can use the chain rule to differentiate the general point. I'm going to use the chain rule. We know dy by dx will be dy by d theta multiplied by d theta by dx, because then these d thetas will cancel. So if we work out dy by d theta, we know y is 3 sine theta. So when you differentiate this with respect to theta, we'll get 3 cos theta. And then d theta by dx, well, if we work out dx by d theta, we differentiate 5 cos theta with respect to theta, we'll get minus 5 sine theta. But because we want d theta by dx, we need to multiply it by the reciprocal of this. So we'll times it by 1 over negative 5 sine theta. So dy by dx will be 3 cos theta over negative 5 sine theta. And this is the gradient of a tangent. What we want is the gradient of a normal, line L. So a gradient of L will be the negative reciprocal of this. So we'll have 5 sine theta over positive 3 cos theta. Now we've got this gradient, we also know it passes through this general point at P. So the equation of a straight line, m multiplied by x minus x1, will equal y minus y1. We'll substitute in our values. So we'll have 5 sine theta over 3 cos theta multiplied by x minus x1, which is 5 cos theta, will equal y minus y1, 3 sine theta. Now all we need to do is we can expand out the numerator, and we'll move this 3 cos theta to the right-hand side. So expanding this out, we'll have 5x sine theta and minus 25 sine theta cos theta. And this will equal, we'll move this 3 cos theta to the other side. We'll get the 3y cos theta, and then the 3 cos theta times the negative 3 sine theta. So negative 9 sine theta cos theta. So this is the general equation for L, but we need it to look like this. So we've got the 5x sine theta here. We just need to move the y over to the left-hand side. We can move this negative 25 sine theta cos theta to the right-hand side. Then we'll have a negative 9 plus the 25. So we'll have 16 sine theta cos theta. And this is the equation we were asked to find here. Okay? For part B, we're given that L intersects the y-axis at point Q. So I'll label this on the diagram. We've got point Q here. And the midpoint of a line segment P to Q is M. So I'll label this point, the midpoint of P to Q, we'll label this as M. We need to determine the exact maximum area of a triangle OMP. So if I zoom in on this, we want from O to M to P. So we need to work out the maximum area of this triangle as the point P moves along this curve. So the way we can go about this, we know point P is given in the question. We need to work out the coordinates of M. When we have these coordinates, we can use the vector cross product to work out the area of a triangle, because both vectors will come from the origin. So do you want to give this question a go yourself? Think about how point M being the midpoint from the Q to P can help you work out its coordinates, and then use the cross product to find this area. You can pause the video and come back when you're ready. Okay, so welcome back if you had to go. So we've got this diagram, we've got point P, we need to work out point M. So the first thing I'm going to do is to work out point Q, then I can find the average coordinate between Q and P. So we know at Q that x equals 0, and we've just worked out this equation here. So if we let x equal 0, this 5x sine theta term will go. So what we're left with, for the equation of a normal, we'll have negative 3y cos theta will equal 16 sine theta cos theta. And then we can divide both sides by the cos theta. So we'll have minus 3y will equal 16 sine theta. So y will be 16 over negative 3 sine theta. So we know at Q, we'll have the coordinates x is 0 and y is negative 16 over 3 sine theta. And we know at P, we've got the coordinates 5 cos theta, 3 sine theta. So at M, the x coordinate will be halfway between 0 and 5 cos theta. So 5 over 2 cos theta. And the average y will be the 3 sine theta minus the 16/3 sine theta, all divided by 2. So it's just the mean average of these 2 points. Well, I can tidy this up because this 9 over 3, and then we'll have the 9/3 take away the 16/3. So the general coordinates for M will be 5 over 2 cos theta. And we can tidy this up, we'll get negative 7 over 3 divided by the 2. So negative 7 over 6 sine theta. So this is the general coordinate for M. So if we know point M and we know point P, we can work out the area of this triangle using the vector cross product. So the area will be 1/2 of the magnitude of O to n crossed with O to p. And to cross O to n with O to p, I'm going to write each of them as a 3-dimensional vector. So I need to introduce k. And because it's 2-dimensional, we know the k component will be 0. So the area will be 1/2. We want I, j, and k. O to n. The I component will be 5/2 cos theta. The j component, negative 7/6 sine theta. And the k component, 0. And for p, the I will be 5 cos theta. The j will be 3 sine theta. And again, k will be 0. So we can work out the determinant of this 3×3 matrix. And the area will be 1/2. When we have the I term, we're multiplying this one by the 0 and this one by the 0. So we'll get 0i minus the j. Again, we've got a multiplication of 0 and here. And then plus the k. We've got 5/2 cos theta multiplied by 3 sine theta minus the negative 7/6 sine theta times the 5 cos theta. So we can add these sine theta cos thetas together, and we'll get the area will be 1/2 of k 40/3 sine theta cos theta. Now we can rewrite this sine theta cos theta using the double angle formula. So we'll have the area, the 1/2. If we take the magnitude of this, we'll get 20/3 sine 2 theta. And now we know between 0 and pi/2, the maximum sine 2 theta can be is 1. So we'll have the 1/2 times the 20/3. So the maximum possible area will be 10/3 units squared. Okay? Well, thank you very much for watching. I hope you found that useful. If you did find that helpful, you can download lessons on conic sections from my website, mrmathematics.com. I'll leave a link in the description below.